Hello, everyone. Привет, Москва. Welcome to our next talk. And welcome our speakers, Romulo, Cintra, and Javier Fernández.
Hi.
It's foggy in Moscow right now and weather not so good. And I heard that the weather in La Coruña is also not very good. Can you?
Yeah, not as bad, but
Javier?
not as bad, but yeah, we know how bad weather it is.
Yeah, I was in La Coruña once at a WebAssembly face-to-face meeting, and the city is awesome. And it's a bit different from the rest of Spain, I think, the culture and other things. It's really cool.
Yeah, definitely.
And the food, it's awesome. To be honest, the food, it's one of the most fantastic things we can find in La Coruña. Unfortunately, I'm in Barcelona, and the weather is great, but the food, I think, Coruña is the best one.
Yeah, difficult to compare.
And how's the weather in Barcelona right now?
Well,
I think it's much better than we have.
When you have good weather all the year, it's really difficult to tell that the weather is bad. But today it's a really, really cold day. We have kind of 10 degrees, I think. Sunny, but cold. But of course, compared with the Moscow, maybe we have excellent weather, yeah?
Okay, and you both work in Igalia. Actually, in Russia, I think many people heard about that company, but not so many people know what exactly Igalia work on. People know that Igalia works on TC39 and some standard bodies, but maybe you do something else also interesting.
Maybe Javier, do you want to
I can do
take this one?
Quick introduction.
You are the old one in Igalia, yeah?
Yeah, since this is a JS conference, the most relevant part of our work is the work that Romulo and the compilers team is doing in TC39 and V8 and JavaScript Cove. But we also work on we have a web platform team which work more horizontal web platform features, and we also contribute. We have our own WebKit port, WPE, especially for embedders. We also have an important team in working on graphics, especially on all the Linux stack. And in general, any interesting open source area that is appealing to us. So we try also to be on top of what is going in the open source community.
Awesome. And I totally forgot to introduce myself.
But everybody knows you. Yeah, you are famous.
Yeah, but anyway, I will say a couple words. I'm Sergey Rubinov. I am currently unemployed, and I work with the TC39 as an invited expert. And I'm also a participant of WebAssembly community group, organizer of Moscow.js meetup, Beer.js drink up, and certified beer sommelier. I think that's all necessary information. And can you introduce yourself, guys?
Well, I'm Romulo. I love beer. It's a good thing because I just understood that Sergey is an expert. I work at Igalia and also part of some bodies of standards like TC39. I'm chairing a Unicode group for message format. Do lots of open source as far as I can. And Google developer expert in web technologies and a few more things. And but at the end, I'm a web guy that loves web and loves to share about things.
Hi, I'm Javier Fernández. I also work for Igalia. As Romulo has said, I'm part of the web platform team, working on different browsers. mainly WebKit and Chromium-based browsers, developing web platform features, which perhaps the most remarkable one was CSS grid layout that we helped to ship thanks to Bloomberg sponsoring the feature. And yeah, that's what we try. Trying to make the web platform more open and allow other contributors other than browser vendors to push the web forward.
And Javier is also contributing to IPFS spreading around the browsers, yeah. And I think it's also a great thing.
Yeah,
and also it's part. Yeah.
And before we start to talk about IPFS, I want to remind everyone that you can ask your questions in the chat, and you can join discussion after the talk. And I think we can start.
Well, yes, of course. I take this one. Well, first of things, I just have to say really sorry because I have a delivery here and I just canceled the delivery and the guy just came at the moment of starting the talk. He had all the day and just came at this moment. Well, let's start the talk. Today we're going to talk about IPFS. That is Interplanetary File System, or stands for Interplanetary File System. And we're going to talk Interplanetary File System, IPFS, in JavaScript ecosystem. But before we talk about these on the JavaScript ecosystem, we go through a kind of a beginner's guide or 1-to-1 or 101 understanding of how it's IPFS. And I will start. We already introduced ourselves. I'm just remarking here that if you want to follow on the social media or my YouTube channel or so, you have here my Twitter and YouTube handles. And Javier has also his ones here. And well, let's start. Also, if you want to just share on the social media, if you want to ask me and Javier to just answer your questions or share anything that you prefer with us on the Twitter, and so we will try to answer all your questions if you just use this handle, IPFS Node.js or IPFS JS as well. It's okay. We will follow all of them. And now let's definitely really start. Main concepts to understand this talk or to get or jump on IPFS on Node.js or IPFS in JS. It's first blockchain. Well, what is blockchain? I will try to give you a very simple explanation because this is only a distributed ledger that has a list of records. But for us programmers and software developers, it's kind of a linked list where we have the previous hash from the previous element of the list, and we store information that use like a chain list, and that information it's stored as a Merkle tree. It's also something that we maybe are used to, and all these connections between the blocks, something that we call the blocks in the link the list will be elements of the list. Those are kind of certified and stamped by a timestamp, and so it's just a connection between different records that are hashed and connected with each other, and they are a blockchain. Yeah. Other simple concept is the decentralized web. It's the same than actual web, or very similar, the main concept, but underlines in different foundations. While we in the regular web, and we will explain a little bit later, it works as work with the centered or centric distribution of the content on servers and data centers, and so the decentralized web spread all that responsibility over different peers. Yeah, and this is the main difference. But the main concept, the main idea of the decentralized web, at least for the final use, is the same, but underlining in different foundations and different principles. IPNS and DNS links. Well, as we know, URLs in the typical web, the location like holyjs.com, are the DNS that we know. Interplanetary file system has their own system to facilitate the searching or the searchability of the contents. Interplanetary name system and DNS links are the responsibles for that. IPNS, it's kind of an address, a static address for our IPFS assets. And DNS links is kind of a bridge between that IPNS address to a real IPFS gateway, meaning that you can have your site, your DNS records on your site pointing to an IPFS gateway, meaning that it's a kind of way of migrating your actual assets on the web to our IPFS world without people noticing too much. Yeah, peer-to-peer communication or peer-to-peer sharing. Well, peer-to-peer is the process of communication between two different parties. Like I'm communicating with Javier or Sergey, but using a communication protocol where people serve content between different instances and different people. And all the IPFS things that you can find also in the website. They have a glossary with lots of terms that you may be familiar. And to get started, they are very, very, very important. Well, before we have this minimal understanding and knowledge, what is IPFS? And we're going to start with like IPFS 101. Because it's important to understand what is IPFS. It's not just interplanetary file system, but this is a distributed system for storing and accessing data over the web. You store information, you access information. Well, you may think, okay, we are already doing that with the cloud, with our Google Drive, Dropbox, etc., or even with websites. Well, that's true, but this is completely different, and I will explain you why. Because the traditional web works like in a very linear way, where you are seated at your computer, you go to your search engine, you search by a URL of a video platform, or just store your website in S345 server, and that's okay. Every time you access your there is a game of DNS resolution that goes to a server that is in Russia and UK, in Japan and US, and brings back to you all the content from that server. But yeah, it's the old-fashioned www way of working with the web. As you know, sometimes a DNS record fails, or sometimes a server fails, and we just don't have that page working, or we just don't have our website working, or the platform, or the servers, or our bank just goes down, because all relies in a unique placement, is in unique location. This is great, but as we know, and as it's been happening more frequently than we expected from last 1-2 years with the big giants of the internet, this is something that we should really care about. And how IPFS works? Well, it's a little bit different. To be honest, I think it's the future, because he doesn't rely in a unique server. He relies in a series of different peers that are kind of micro servers that share that content and exchange that content with others. If we use IPFS to share our video platform, our website, or our medical records, or any other thing, we won't never lose the information, because the information, if one peer goes down, you have always a backup, always an alternative. And it's not an alternative that it's a physical server. Could be a physical server, could be your computer, my computer, your computers from those that are listening to this talk, and we will have a more distributed sharing of content. And why IPFS? Because we are saying that traditional web works in one way that is very focused in content in a data center, let's say like that, and on the IPFS world, everything is distributed and spread. Well, there are a few things that are beneficial when you are using IPFS that traditional web doesn't have. First, we have integrity and verifiability. These words are quite difficult to pronounce sometimes, but one thing is important. When you go to our website like fish.com/demopng, and after a few hours, a hacker or even our engineer that forgot to upload something, few hours later uploads an image of a different fish, a blue fish, with the same name. For the final user, it's the same thing because the actual web is location addressed, based location addressing, meaning that that URL, that link will be unique for any content. You can have fish, but you can have anything else there. Could be even not a fish, could be a cat, or could be something worse for us, meaning that our browsers, our way of searching the internet based on location addressing doesn't check integrity and doesn't verify if the content that you want to see is the real content that we are looking for. This is very problematic. We don't notice too much this, but this is really problematic, not because the fish or the cat, but if you are doing a financial transaction or anything that requires a verification of the content, because could be always a man in the middle that just change the fish and add the cat, yeah? And this is something that in IPFS doesn't happen, because when you upload that fish or that image, that content, everything that goes through IPFS network is hashed. I will explain a little bit later how this works, but a unique hash is created based on the intrinsics of the content, meaning that even if we upload a different fish and we keep the same IPNS, the same URL, things will change because the verifiability or the integrity of that file changes. We have a fingerprint for each file, meaning that he will pick the new one, or if it's something wrong, could be some risky operation that we are doing, meaning that we have extra layer of security and integrity on our systems when you use IPFS to exchange files. Yeah. Meaning that, giving a brief conclusion on that first, why IPFS? First, integrity and verifiability. Wrapping up, the actual internet is location-based addressing, meaning that, as I said, you go to that URL /demopng, and everything that you place there, even 1 gigabyte image.png, will be the same always for the final user, because we don't check the content itself. On IPFS is content-based addressing. We search by the content. We're not searching by that URL. We just search, I want that yellow fish. On internet or actual internet, everything is mutable. On IPFS, it's immutable, because if you have a new thing, you just generate a new hash. And the cool thing about hashing that we're going to see also soon, there is some chunkers. When I talk to chunkers, for those that do web, like I think a majority of us here, we have Webpack, we have Rollup that separate our files and our JavaScript in little chunks. IPFS does something similar, separate that content in small chunks, and some chunkers are so optimized that can check parts of different chunks to give you back the content. Imagine you have two yellow fishes. One uses Google's and other doesn't use Google's. Some parts of the fish are common. Some chunkers can also go to that level to just match that content. That will be the duplication that we'll talk just now. And just to finalize this part, on the actual web, use trusted sources, centralized trusted sources that can just go down like a server. And on IPFS, we can fetch from anyone in a distributed way. Everybody that has an IPFS node running can be your server, meaning that you can just push data from your neighbor, or you can push data for as much close as you are, saving energy, saving bandwidth, etc., etc. I was just giving a spoiler a few minutes ago about that duplication and content hashing. What I meant before, and I will explain right now, is for IPFS, content is always the same independent of the naming. Imagine the fish demo PNG is a yellow fish, demo 2 is a blue fish, and demo 3 is the same fish from the first image, meaning that when we hash that content, it's like hashing a password, yeah, with our keys and with a cryptographic key. Same things depending of how you do it, but normally same things can give you the same results, meaning that the same content we have on yellowfish will be always the yellowfish. But imagine, I was talking about chunkers. When we create a chunk, maybe we can divide in different parts. Those different parts of the file could be reused across other files, meaning that if we have the same fish with different parts, like with the Googles, or just half fish, or fish with teeth in the mouth, this part will be the same for both. The chunk that takes care of just hashing this part will also be able to share that content. Normally, it doesn't happen like that because they are chunked in nodes, but lots of works and POCs are done to just improve this part of the content hashing. And talking about content hashing, something that also is very important is to explain how the things works, because I told you we go to a server normally on regular web. Server brings back our content based on a URL, fish.com/wherever. On IPFS, it's similar and different at the same time, because we have something that we call wants list, and we use a module that with BitSwap. What it does is, just every time I request a file or IPFS thing, I have the seed, the content identifier, that is the hash that we've been talking so far, and I just send to my connections or to all my peers connected around, see, do you have those content identifiers to share with me? I want an image, I want a presentation. He will just go to your neighbor's computer or any peers that you are connected and ask for those. If they have, they bring back that content. If they don't have, well, we have distributed hashed tables that are kind of similar to server address that are distributed as well, or on over the network, where we store also more and more information, meaning that you can ask there, oh, someone there has those hashes, and they will try to get back to you. Or if they don't have, they will start getting to a different distributed hash tables until your data it's provided to you and it's retrieved to you. Well, you may question, well, if doesn't exist that data anymore? This is a good question. IPFS is not the mainstream way of storing data right now, but in future, if it will be, we don't have this risk. But today there are also some services, and you can also just do some of the things that stores your content forever. They work like a Dropbox or like a server that stores your content, just in case of that content it's eliminated in all the nodes, meaning that works as a fallback. It's not just to rely on that content as we rely on the actual web, but it's just a way of complement that actual web and make even better, yeah? Just to have like the source of truth there, just in case we need. But if my surrounding area has those files, you will retrieve from that files. And how it works, just briefly. I just give some hints on how it works. I have an image as an example, and I go through IPFS process using a command like IPFS add, and I have my doc image PNG. What happens is, depending of the hashing algorithm and how chunks will split my image in pieces, they will create a tree where small pieces with the same size, by default 256 KBs, will be just created equally, and each one will receive a CID as well, because this will be a tree. They will start from the bottom of the tree, composing the tree, could be directly linked to the main node or linked by themselves. I just represent here kind of a mixed link here. And they are stored on the main node as a part of the main node, meaning that we have a seed for the node, and the node internally had links to other seeds, meaning that when we search by this image, we search by this hash, not by this one. But this hash is composed by the hashing of all of those, and at the end, we compose the node hash. And when we bring back the node hash, we will have the links, and the links will retrieve all the rest. Meaning that if I have kind of an image that shares the same content, possibly this hash will be the same, even if the node is different. Meaning that we can have this node, and if the doc is just half of the doc on the image, probably this hash will be the same, and we have the duplication and optimization of the resources. Of course, this is nothing that exists actually. There are some proofs of concept based on that, but it's nice to know. And a little bit about seed, the hash that we've been talking. During those years, different formats, different ways of composing the seed were being done. Because one of the most important things about the seed is all the intrinsic information that is hosted there, because you host the CID version, the format, the multi-hashing, that is the hashing of different parts of the seed, and lots of different versions arise since this was created. The most popular one is the seed by itself, that normally starts with the QM, and we also have a very used or popular one is the basic 32 seed V1, that also is kind of a superset of the original one that has more information and more context based on different things. Both formats are very common to see over the internet. I just give you a highlight of that. Remember, when we have this QR code, you can just take a picture and go through documentation to have a better understanding of how things are on this part. Well, now I will just hand over to my colleague Javier, that is an expert and works on IPFS a lot. Javier, the floor is yours.
Thank you very much, Romulo. Yeah, the great explanation, and every time I'm listening, I learn some new things about this IPFS protocol, which I can start saying that it has just two basic ways of operating with the protocol. Perhaps the simpler way and the most implemented in browser is through the Ipfs Gateways. So whenever the browser renders a site that has an IPFS URL, the browser handler it and redirect through HTTP protocol to a gateway. And this gateway is responsible of reaching the actual IPFS content through the process that Romulo explained it before. And the other way, which is a bit more ambitious, is the IPFS native protocol, so that instead of redirection to a centralized gateway, that it also has the issues that other central nodes have, that it may be down or so. With the native protocol, is just the pure peer-to-peer communication. You just transfer the files between the local nodes. That's a more ambitious goal of the IPFS community, but it takes a bit longer for getting support in different browsers. And about the what kind of browsers, perhaps is worth mentioning Brave, which support both mechanisms. You can use the extensions to use the redirections to the default gateways, but you also have the chance to install a local node and just allow the browser to redirect the IPFS request to your local IPFS node, which then use the native protocol to proceed with the data interchange between the nodes. But there are other browsers that allows you to play with the IPFS protocol. Firefox has some extensions or add-ons that you can install that use the redirections to the default gateways, and also all the Chromium-based the browser have basic support for through extensions as well. You can install the local node as well and play with Chrome, Brave, Opera, and Edge right now, which is also based on Chromium. And so there is this IPFS community group which is pushing forward to get more support in different browsers for the IPFS protocol. Yeah, that's what. Are we distributed yet? I mean, is this still available in any browser? Unfortunately, it's not there. There are a lot of work there, and that's why Igalia is helping the IPFS community to improve the support in different browsers. Perhaps the Chromium base are the ones that are leading this effort, but we aim to get this support to other browsers as well. And yeah, that's why we are working since several years with IPFS community to improve this support. This implies a lot of work in different aspects, different specs from cross origins and security, and many improvements in the Chromium and WebKit and Firefox layers. This is a brief list of the first contributions that we made. We implemented some basic extension support for Chrome, allowing the web extensions to be handled as cross origin, a secure cross origin, because before that web extensions didn't were considered like that before. We also improved the concept of secure context in Firefox, and in WebKit, we have plans to do the same, but we are a bit stalled right now in the discussion of these local host and loopback redirections that are not considered a secure context for several reasons, and that makes very difficult to add support for dealing with the local IPFS node. So this work is still in our plans, but it will take a bit longer. As I said, one of the first tasks was to get a more consistent concept of what is a secure context. When a site has a IPFS URL and the browser needs to redirect the the request to a different context, we try to. There were many parts around the Chromium code base where this secure content was defined, and we discovered, we found out that it was not consistent with what the spec stated. So we landed several patches in Chromium to make this be more consistent itself and match what the spec is saying. As I said, the WebKit implementation is a bit behind, but as I said, we have plans to work on this in next years. And then we proposed recently to Chrome engineers a new way of handling these protocol redirections, what we call, or what is called in Chromium nowadays, predefined custom handlers. As I explained it, there are several ways where you can instruct the browser to handle a protocol in a different way. One is the web extensions. You have to install it and say that from now on, this protocol will be handled through these gateways, for instance. Recently, Microsoft shipped a feature that allows progressive web applications to also behave as custom handlers. So this is another way. Both mechanisms have different security and privacy considerations, but both are similar in the way that you have to install third-party software to allow the browser to handle the URL schemes in a different way. So this new approach, the predefined custom handlers, the idea is that we implement those handlers natively in Chrome code, and the authorization and security checks will happen in a different way. We are thinking on several approaches, but it's a different approach. As I say, the main goal is to avoid the third-party software, but also simplify the user confirmation. Our idea is that these predefined handlers will ask the user for authorize the redirection just at runtime and once the first time the handler is used, and then the user decision will be stored via user preference, and also another goal is to make easier for embedders of Chrome, in this case, to introduce handlers for new schemes. Because nowadays, if you want to say that another protocol scheme is introduced in the safe list of the web extension specification, for instance, you have to start a discussion with the community, and this could take a lot. And for some cases where embedders are pretty sure that this is only valid for a specific use case, having a predefined handler for this, like for instance Chrome OS has for WebCalc or Mail2 protocols, this make easier to add these new handlers for these new schemes to be handled internally. And this is how the current design of the protocol handler logic in Chrome, which lives in the Chrome layer. And as you can see, there are several dependencies. This is the general Chrome, very simplified Chromium code-based architecture. And the main dependencies are from different components that, as we can see in the next slide, the first proposal is to move all the protocol handler logic to the content public API. The content public API is what Chromium embedders will use to define their own services, components, logic. In this case, the idea is that they can use this new content public API to implement their own predefined protocol handlers. However, this design has different issues, and is the dependency with other components. The content layer is designed to be independent on the upper layers. So agreeing with Google and Chromium design engineers, we will propose a new approach, which is based on create a new component, a new custom handler component that can be better integrated in the Chromium architecture and solve most of the dependency issues we have. We still have the Chrome and embedders like Brave or Opera would need to implement their own delegate, specialized classes for the delegate, and factories for the protocol handler registry, so they can create the appropriate instance of the protocol handler registries that can then redirect the URLs according to the predefined custom handlers.
Well, Javier.
I hope I wasn't too narrow in the technical details, but I can clarify any question you may have.
Well, we will continue, and if questions arise, we are really happy to answer. Well, now before we go into a demo, we also nice to mention few user cases that we can do on IPFS. With all this implementation that also my colleague from Igali and his team is doing for bringing IPFS to the browser to be as native or as any navigation we do, there are lots of use cases for IoT, payments, P2P activities, sharing information. The original goals also that was storing information for never disappear, because if the information is spread around the internet, also it's difficult to have this censorship, also to control version on the information. Ethereum, wherever. There are lots of use cases that can be applied on IPFS. And talking about IPFS also on the JavaScript side, because we are here because JavaScript and Node and JS in general. We're gonna do a quick demo about using the IPFS GS library. Just to mention that the original implementation it's like in Go, but the GS API is paired with the Go APIs and CLI, meaning that we now have the same as Go people has, but in the browser and in Node. And it's really easy to get started. There are lots of things to get there. I also, we're going to share the slides at the end of the talk, where you can just have links or have, like here in the right corner, just option to jump to the real documentation and see how it goes. Now it's demo time. It's a very, very, very quick demo and very simple demo to see how IPFS works and how are the tooling, how can we develop something and spread that thing on the IPFS network. I will try to be quick because I'm seeing that time is not in our favor, but I will just do a quick demonstration about IPFS Works. And I will start with IPFS. Yes, sorry. IPFS, yeah. I'm a little bit nervous. Oh, what is happening? Sorry. The CLI of IPFS GS. Oh. Let's start. I will start by the server. Not it's demo. well, I will start by the server and demonstrating what we create with the server. Sorry. Well, first of all, I just created here a simple code with the Fastify server, where the main goal at the beginning will be upload a file. Yeah, it will be a simple file. We have a server, a local server, and we have our IPFS core, where we just create a new instance. Thanks for the global wait for allow do this on Node. And here we receive the post on our URL upload. We will receive the file. And now we just add this data, this raw data to IPFS. A CID will be generated and we'll just print and send back to the user that. Meaning that if I go here, I pick a file like documents and this file, go here, I just do a call, I received the CID, and on the console, I just printed that this hash is the content hashing. If I go with this hash to a browser, as an example, and I just do IPFS, and I just place this hash, I just see this image. If you see here, I'm going through the IPFS gateway /IPFS and just placing the result of my server gave me when I upload that file to the network. Now this file is over the IPFS network, just like that. And for those that are using, as an example, the Chrome extension, they can connect to a server, and instead of like in this case, I can just change for embedded Chrome companion, where my IPFS node will be generated directly from the extension. I just can go through this. I do like that. And if the server is running, in that case, we'll go to localhost 9900. That is our local node. I am having some technical troubles with that. But well, let's continue the demo before we explain a little bit more things. And a cool thing that we can do is also, instead of just uploading a file, what we're going to do is upload our presentation and also add something that it's related with IPNS. It's just get the seed and publish that seed on the network. I already have here some code already prepared, just to not rely on the gods of the demos. And what is happening here? Well, I have an address of IPFS. I just have the CID that I showed you when we upload here, the same one that when I upload here. And what I do is I'm using the IPFS API that has the name, and I publish this on the IPNS gateway, meaning that this will be also available as a static file or with a static address on IPNS, like a domain, where every time I publish something new, independently that the CID changes, will be available on that part. I will just restart the node because I'm not having a watcher there, and I will do just maybe I will just pick a new file and send that new file. Sorry about my desktop organization. Maybe this is projects, IPFS, and I will just pick our presentation of Node of IPFS here that we've been talking today. I will just send my presentation, and well, two things. First, I have my presentation on the IPFS network, and I have my presentation on IPFS gateway. If I just go through the browser, I would be able to see, if I just change this, our slides that we've been talking about. They are already on the IPFS network. If we use a browser like Brave, as an example, you will just be doing something like this, and you will be able to also have this. On Chrome, it's not working, but on Brave, you can try this, and then you have it. Before jumping to different things and different parts of the talk, because we are very limited, I just want to share also something that is really cool and really important. When you have a local node of IPFS, you also are able to search and go through different things like your connections, and I'm having quite some troubles here, like through your connections of files, and you can see each CID that you just uploaded. You can have the vision of specific links that has each chunk, as I explained it at the beginning, because we just create here our node, that is an example node. And then inside of that node, imagine the PDF I just upload has several links. Each chunk represents a link, and each link has some data. And if this needs more data, will be another chunk. And this is also cool because imagine I just upload this one will be a JavaScript file. It's a simple file because we can upload anything that we want. He just create this main node with two different files. Yeah, you see these CIDs, you see this one, and if I search this, we'll retrieve on IPFS the main JavaScript file. You can search by different chunks, but of course, depending on size of file, will take much more time to process the file and release it on the network, because he needs to kind of process it and upload to the network. More cool things about all these parts of IPFS, as far as I remember. Well, you have our presentation. I will just copy this on the link. And this is just a brief demo how IPFS works. I will go back to the presentation just to finalize it, because we have something that is really important that we want also to mention. That is the ethical decentralization, because IPFS, it's a new way of sharing and spreading files across the internet, but also is something that we should be very aware of, because this brings us digital freedom, because we don't need servers to share our information. We break the silos of the web, because we decentralize everything, but also we should be careful about how censorship could be bad or good in certain ways, because we also, unfortunately, we have many bad actors on the internet right now. And not sure, Javier, if you want to share something about this part, ethical part as well.
I wanted to remark that, this is perhaps the main reasons why Gali and IPFS are collaborating to bring more support for any browser for this protocol. And if the web platform needs to be open, you must have to have the freedom of choosing any browser to be able to navigate this network. And this is where the nature of open source of this browser is very important. We want, or we are using the ability of contributing to this browser so that we can provide the easier way of accessing without the need of installing third-party software that needs the user to verify the source, and that's perhaps the key argument I want to do about this.
Well, I think that are the last parts of the presentation. During the QA, I will try to also to get all the demo up and running to everybody. And I think it's all. We are on time, and just want to thank you everybody that was watching the presentation. and following us up.
Thank you very much.
Thank you for the talk. And we'll have some time before we go to discussions. Everyone who wants to ask questions or discuss IPFS, you can join us on Zoom. Or, I want to talk a bit about ethical moments and decentralization. Sorry for my pronunciation. I think that's the most important part. As for me, it's the most important part here. And on the internet, where some companies want to own part of internet, the decentralization is a very cool thing. And do you think that our browsers may integrate IPFS like Brave did it, to not use extensions, just use IPFS?
Yeah, I think there is a real interest on that, but there are many issues that needs to be discussed and addressed, like as I said, privacy and security, because these redirections needs to be verified. So I think the interest is there, but there are still many technical issues that needs to be addressed.
Yeah, I think I feel the same. I feel that a shiny future for IPFS it's around, because with all this hype about NFTs, about Ethereum, about blockchain, also helps IPFS, because there are few providers of service that are already using IPFS for NFT, like Pinata. We have Falcon also sharing files. There are lots of motivation and drivers to move the web further. About the browsers, Javier knows much better than me that what is going on inside. But I think also the power of community and the normalization of IPFS as also a main or a de facto standard, as well as HTTP or another protocol is, it will help browsers on board and watch this as a first citizen of the web.
Yeah.
And since we have a bit more time, I want to ask another question. How is it hard to debug something using IPFS? I mean, in browser. Is it possible to debug it with just dev tools which presented in browsers?
Well, you have. I was about to present. Let's see. We have you have the CLI, the IPFS CLI by itself. Yeah, you have this CLI that this is the Go version, where you can just try to resolve. You can have the debug mode, and you can have all the tools to just start your daemon, just to develop and debug everything on the IPFS. Meaning that at level of tooling, IPFS it's very well served. Yeah, and also you have this CLI version, but as I show on the internet, you also have this that you with any CID on a node or something, you can quickly search through and see how many peers has this, how it works, how the things are. Meaning that debug, it's really cool. Imagine also you can see the file itself. We were debugging this file, but you can see on the gateway. Well, yeah, it's. I think at level of tooling, it's very well done, and I think they bet a lot or invested a lot on the initial tool to provide developers like us to build products on top of.
Yeah, we need to wrap up. So thank you for your talk and demos, and thanks for everyone who was with us. Please join discussions. Don't hesitate to ask questions in Russian. I will translate it to English. So, yeah, I think that's all. Thanks, everyone.
Thanks, everyone.
Thank you very much to everybody.
Thank you very much.